Let's have some fun, possibly learn a thing or two, but mostly have fun, let's be honest. Right, I am going to talk about an awful lot of things today because I am that sort of a person and that's the sort of thing that I do. Predominantly, I'm going to talk about machine learning. I'm also going to talk an awful lot about RMS Titanic. There it is. That is a boat. I'm given to understand. So, let's get started with a bit of detail. First, the second most common question I get asked at conferences is, where are you from? That is where I am from. I am from the county of Shropshire. The first most common question I get asked at conferences is, who are you? Oh well, there we go. It's the third most common. Where is it? The Shropshire is a landlocked county. Consequently, this is the largest boat I have ever been on, making me uniquely qualified to talk about something like RMS Titanic. This is the little ferry that goes across from Liverpool to the Isle of Man. I was on it in a storm. It was, shall we say, not pretty. I looked out of the window at one point and realized I was looking down into the water. Yeah. So, what is machine learning? Briefly. AI is a buzz thing at the moment. Everyone's talking about it. Jodie gave a lovely talk about it for our keynote. AI is a thing, but machine learning is a subset of AI. All machine learning is AI, but not all AI is machine learning. There is a subset of machine learning, which is deep learning. I am not talking about that. We are sitting right in this little stripe here. That's what we're talking about today. Machine learning has been around for an awfully long time. It dates back all the way to the 1950s, and the very first machine learning application was actually this gentleman here who used it to teach, in inverted commas, a machine to play drafts, or checkers as it's also known. I'm not doing anything anywhere near so useful or entertaining, but we do what we can. What is machine learning used for? It is used for image recognition. We've probably all come across this. If nothing else, sitting in car parks and getting your plate recognized, that's machine learning. Translation. If anyone sees Rendell about, they're playing around with an auto-translated system that projects translations of what people are saying around you into your glasses. This is pretty wild and amazing stuff. Still basically machine learning. Fraud detection. If you've ever had yourself suddenly get your bank transaction paused because something looked odd about it, that's probably an automated machine learning system that's saying that this transaction does not resemble the others. They were in the UK yesterday and now they are in Denmark. What's going on there? Very suspicious. That sort of a thing. Recommendations. When you pop along onto Amazon and say, what book should I look for? And it'll save you a list of recommendations based on what you have previously looked at, or even what other people like you and is clustered with you have looked at to give you similar ideas of what you might like. I have written a book on C#, and whenever I go on Amazon, it recommends it to me, which is marvelous. I mean, it's a good choice. I like the book very much, but I already own more than a few copies. Maybe I'd like some more, who knows. Detecting medical conditions, that's a biggie. That one's used in hospitals. It's not the be-all and end-all of a diagnosis, but it can do things like take a lot of the legwork out of looking at x-rays and stuff like that and trying to decide whether this needs further attention by a human being or not. And predicting the future. That is another avenue. It's predicting what is going to happen next based on what has happened already. Now, machine learning is actually basically statistics. I mean, that's the big that's the do not look at the man behind the curtain sort of a thing about machine learning. It's statistics. Most of it is statistics that you can look up in books that predate computers. But it's applied by a computer on a level that a computer can do it with the amount of data that a computer can crunch, which is infeasible for a human being to do. Which is, how does a machine learning process look? It's something like this. So you start off with what they call the training data. By training data, we just basically mean stuff we already have, often already labeled. Quite often what you're trying to do is apply a label to this data, a yes, a no, or a value, or something. You're trying to generate a value for the new one, and for that we also need all the old ones. We need all the old ones which have already been labeled up or answered, or whatever it is that we're trying to achieve. Having done that, we create a trained model. The trained model is what's actually going to make our prediction, and it generated based on that old data. And then once we've got our model, we can make our predictions. The prediction is, given all the old data, given whatever other stuff I've entered into the system, given this new data, this is what I think it will be. And that's how the process works. Sounds simple, kind of is, kind of isn't. So the best place for going to learn into machine learning, if you want to get into it, is Kaggle. Anyone know Kaggle? Yeah? Yeah, a couple of Kagglers. I can see a few Kagglers. That needs to be, if that's not actually a term, it needs to be now. Go forth and use it. So Kaggle is a great resource. I use it for all sorts of things. It's got huge amounts of interesting data sources you can use in it. I did a talk not long ago on basic machine learning algorithms and how to write them out in something like C# or even Excel, which, believe it or not, is not that hard. And I used a data set from Kaggle, which was Pokemon. It was all of the Pokemons. Is that the plural of Pokemon? Pokemons, and all of this heights and so on. And that's all that stuff's there. There are challenges all over Kaggle as well, so you can take part in challenges. I believe some have cash prizes involved. It's a pretty good site. Their hello world of machine learning, as they call it, is the Titanic challenge. And that's what I've come up with a little simple solution for this talk. So this is, given the details of the passenger manifest of Titanic, can you predict whether or not a person would have survived based only on those details? So the label we're coming out with at the end is survived or did not survive. It's a magnificent data set because you can go as deep and ridiculous as you like, and it's real world and it's got all that sort of real world, this is a bit gooey, this data, it isn't type perfect. So it's a great training exercise in learning how to put a machine learning system together. And you can submit your score. Some people have gotten it all up into the close to 100%, and maybe. I'm not convinced, but maybe. So RMS Titanic. This was an awfully big boat. There have been many films, books, radio series, you name it. They have been made all about this. I have no idea, to be honest, why it continues to fascinate everyone. Nevertheless, it does. The Titanic was the second, for a little bit of historical detail, because I'm a nerd and I love this stuff, of the three Olympian-class ships. There were three: Olympic, Titanic, and Britannic. Titanic was the middle one. Britannic never actually got used as a passenger liner. That was sort of co-opted into this sort of a war-type thing that happened around 1914 and became basically a floating hospital. Bits of Olympic still exist in the UK, and if you know the right restaurant to go to, you can actually go and have a meal in basically the lounge of Olympic. It's still around. Funnily enough, the lounge of Titanic is a little harder to get to. People have tried with varying degrees of success. This is Titanic being constructed in Belfast, in Ireland, which, yeah, there we go. And then it was meant to depart from Southampton in England and then reach New York over on the other side of the Atlantic. That was the plan. Things went, as they say, a little pear-shaped. It didn't quite make it. So the people on board Titanic, according to a documentary I saw once, the upper decks are inhabited all by these lovely people and Billy Zane and all of this, and that's all gorgeous and wonderful and the rest. And then everyone else, it's kind of like this. It's like they're all Irish and got hay bales and playing fiddles, and I'm sure that's exactly what it was like, and this is not an over-romanticized view by a slightly overrated director. Anyway. Why was it called RMS Titanic? Bit of trivia here. Royal Mail ship. It had a mail sorting office on board. Part of its duty wasn't only transporting passengers, but also to transport mail. Those birthday cards may not have reached their destination. This is what the cross-section of Titanic looks like. Now, this does actually have some pertinence to our model. There were, I think, 7 decks, starting at A deck, the promenade deck, B, C, D, E, F, G. They were lettered. G is right down in the cattle class by the waterline. And how good a cabin you had, to a degree, determined how far up or down in the boat you were staying, which is relevant. The journey of Titanic. It departed Southampton on the 10th of April. It made a single... Well, here's the thing. They call this its maiden voyage. It's maiden voyage from Southampton. The maiden voyage is its first voyage. It was constructed in Belfast. Belfast is famous for many things. Being in England is not one. Therefore, I would perhaps propose that it was not really the maiden voyage. I don't know how this works. It was the first voyage where someone actually paid to be on it, I suppose. Anyway, rant over. Southampton on the 10th of April. It made a single scheduled stop at Cherbourg and then another in Queenstown. It's not called that for some reason anymore. And off then into the Atlantic. It made good progress through the Atlantic up until the 14th of April, where it turned the corner. Apparently there's a corner, and never made it very much further than that because it encountered this gentleman. So this is an actual picture of the actual iceberg, in case you were curious. That's the one. That, of course, is the iceberg that struck Titanic, causing it to start taking on water. There's a lot more complicated stuff that I'm not going to go into, but basically ship sank. In fact, it broke into two pieces, as demonstrated in this sketch made by one of the eyewitnesses. As it went down, it broke into two pieces and then sank to the bottom of the Atlantic, where it remains to this day. There were lifeboats on board, but for various reasons, which stagger the imagination, they decided it was not worth having enough lifeboats to carry all of the passengers off in the event of the boat going down, which, spoiler, it did. The Titanic has now been down there for well over 100 years. It apparently won't be for very much longer. Advanced rust and decay have set in, so the wreck will not last for much longer now, which is why there's suddenly a bit of an interest in getting down there with subs now, before it's gone forever. This photo, I believe, was taken in the 1980s when the wreck was relatively intact. It does not look anywhere near this good anymore. There have been many films of Titanic, some of them pretty good. Some of them were not. I do not recommend watching any of these films. They are all quite bad. Titanic, the animated movie, arguably the worst. That's the one with the rapping dog. I wish I were joking. I am not. And Titanic 2 has many sequels, including, I think, one set in space and one where the Titanic's like possessed by demons or something. Look, if you like that sort of thing, whatever floats your boat, but no, I do not recommend them. I have suffered in order that you do not. Right, let's have a look at some data. This is our data schema for Titanic. So, survived, true or false. In the training data set, that has been filled in for us. 0 for false, 1 for true, it's Boolean. The passenger class, that is the class of your ticket, first, second, third. Sex. Now, a little note on this. It only recognizes 2 genders. I'm aware that gender is massively more complicated than that, but this data is historic. It comes from 1912, I think it was, and so in those days there was no one on Titanic who openly presented as anything other than either male or female. This is a historic context. If this was a modern boat, we'd probably have a slightly different data structure for that particular field. But I present it in the context with which it was recorded. Age, well, you know what that one is. Number of siblings and spouses, I'm not sure why those are grouped together, but they were grouped. Parents and children, well, I suppose we do begin to resemble each other after a bit. Ticket, the ticket number, how much you paid, the cabin number, and the port of embarkation. C for Cherbourg, Q for Queenstown, S for Southampton. Okay, that's a fairly decent set of data. Now, a little note on this data as well. I say collected from the passenger manifest. The passenger manifest for Titanic is at the bottom of the Atlantic. It has never been collected. It was probably destroyed not long after the wreck, or possibly simultaneously therewith. This data was largely gathered afterwards and often based on the memories of those people who survived. It is hugely incomplete and often not entirely consistent. So that is, although that forms part of the challenge. This is what it looks like. I've added a little bit of color just to make it easier to see where all the different fields are. So we can see it's just a basic, simple, comma delimited file. Nothing complicated there. There were a couple of celebrities, incidentally. This is Margaret Brown. She was became something of a media celebrity after Titanic because of the sheer force of her personality. She was a member of the first class, but amongst other things, she informed a committee of first-class passengers to look after the third-class passengers that survived over on Carpathia, which is the ship that picked them up. She also would refuse to leave onto a lifeboat until the very last second, and basically was told that you get on the boat now or you're going down with the ship. And while on the lifeboat, she insisted they stop to pick up more passengers. Otherwise, as she put it, the gentleman in charge of the boat would be joining them in the water. They stopped and picked up more passengers. There is, amongst other things, a musical named after her, or based on her life, The Unsinkable Molly Brown. Although every single film that has ever been made, including the James Cameron one, has called her Molly, she was never known by that name in her life. That was a newspaper fictitious fiction. She preferred Maggie. So that's her. Also, this lady here, Dorothy Gibson, a silent movie star from the 1910s, one of the very first silent movie stars. She survived and appeared in the first film depiction of Titanic, wearing, as you see in this publicity photo, the actual clothes she was wearing on that night. Unfortunately, the film itself does not survive, so I haven't seen it, and there's chances are no one living today has either, which is a shame, but there we have it. So, where did I start? I started with something called Jupyter Notebooks. Now, this is not .NET, this is Python. Apologies, there has to be some. It doesn't have to be, but .NET is great for many things. Unfortunately, quick data visualization isn't always one of them, and so this is what I use to get a feel for the data, to have a quick look. But it is completely compatible with VS Code, which is where I ran this. VS Code has a plugin for running Jupyter Notebooks, which I thoroughly recommend checking out. So there is a little bit of Python, but not very much. And you can actually skip that bit if you really want to, but I wanted to get a bit of a feel for the data. These are the libraries that I plugged into this. So Pandas and NumPy are for crunching data, for moving the data around, putting it in a format I like, kind of tables and things like that. And we've got Matplotlib and Seaborn, which are for visualization purposes. That makes lots of rather nifty graphs, which give a great way to get a feel for what it's likely to be a good idea when you're preparing your model. And this is kind of the sort of thing it looks like. This is it running in Visual Studio Code. There's little blocks of Python there, and then whenever you do show, which is show is from one of the visualization libraries, it will literally, when you press play, blast out a nice diagram for you. So you could try out a lot of ideas, you can try a lot of quick little data changes, data amalgamations and whatever else to get a better feel for how to separate out these two categories that we're trying to work with. So, and it is only a few lines of Python needed, and you can easily look these sorts of things up. So let's have a quick look at the sorts of things we can do with Jupyter Notebooks in VS Code. This is just a straightforward describe. This is just giving us a look at what does our data look like. So we've got a count and a mean. Now, mean is I'd like to comment on, because most people, when they say average, they actually mean mean. I don't know whether probably most of you may know this. There are actually like 3 things that are average. There is no thing that a statistician will average as such. They'll either calculate the mean or the median or the mode. Mean is what you think of as average. Add them all together, divide by the number. Median is arrange them all in a line in order and then pick the middle one. And then mode is which one's the most common one. Now, if your data is normal form, meaning it's got that, the bell curve, you know those bell curves, it's that distribution, then the mean, the median, and the mode will all agree with each other. They'll be roughly the same number. If they're not, if the data's skewed one way, the other way, or in some other form, then they will not agree. And so checking things like mean and median and so on give you a quick idea of what the shape of the data is likely to be without even needing to go to the stage of diagramming. So as it happens, we have some means and some bits and pieces. Okay, now the count, may pay attention to the count there. 891 on most of them, but not all of them are filled in. We'll be looking at that in a bit. 714 ages, 891 of nearly everything else. So that tells me that a lot of ages are missing from passengers. So that's maybe something to look at in a little while. Okay. This is a method by which we have... So the other thing is, you may notice that there is some data that's missing here. So sex is missing, for example. You won't see it there, and that's because it's not numeric. In order for anything to be processed by one of these things, it has to be numeric. That's just the way it is. There's all sorts of ways of doing this, and some shorthands in .NET that I'll get into, but at the moment in Python, the simplest and easiest way is literally to just create some virtual fields and tell it what number I want the values to be. So for gender, sex, whatever, male and female, there are only 2 values, and so I've made them either 1 or 2. Now, a quick note there as well, the 1 and the 2 do not imply that one is greater or less than the other. It's simply that they are different. All that is statistically relevant is they are not the same number. That's all I need to know. So you could reverse that to be 2 and 1 or 1 and 500, and it wouldn't make any real material difference. Same with embarked. I convert the C, the S, and the Q to 1, 2, and 3. And then there's also fill NA. I don't know if you can see that down the bottom. I've said if stuff's missing, then basically just fill it with some other value. Fill in the missing values with just some sort of default, which may or may not be the right thing to do, but for now, and I've done that with cabin deck number, which I've gathered by taking the cabin number and taking the first letter. Right, let's have a look at some charts to see how this looks when we start playing with it. So this is a scatter graph of how many family do you have in total versus your age and whether you survived or you did not. So the yellow colour representing survival and the blue not tends to suggest that you are there's a bit of cluster in there, but I'm not sure exactly how entirely useful that is. This is survived or didn't based purely on age. Now you can see that there is a little bit of a bump there. There's something interesting going on. The red line, reddish line, represents that we survived based entirely on count of how many people did and age, and or rather density. And the 0 that you didn't. So you can see that for very young people there's a real blip there, which tends to suggest that maybe very young people tended more to survive, and you've got a blip down somewhere in the mid sort of 20s to 30s, which suggests that people of that age had a tendency not to survive compared to those that did. There you go. So this is class, by which I mean not class like D&D. To my knowledge, there were no rangers or acrobats or anything on Titanic. This is class of passenger cabin, first, second, or third. Now, what this tells us is, if we have a look at first class, more people survived than didn't. They paid more money, they got a better cabin, 'twas always thus. Second class, you basically got a 50-50, roughly speaking. And then third class, ooh, not so good. So it would appear that people in third class had rather a strong tendency not to survive. Where did you embark? Did that make a difference? It did. People that boarded at Southampton, they are significantly more likely not to survive. People that embarked at either Cherbourg or Queenstown, less of a difference. Is that relevant? Is there an explanation? I don't know. I'm just presenting the data. I don't know the reason for this. Could it be that folks from Southampton, because they got on first, because they were there when the boat started, were put further down since those were the furthest empty cabins? I literally don't know. But if anyone ever finds the answer, let me know. What about cabin number? Well, this looks like we found something, doesn't it? We've got cabin numbers there that all kind of look similar-ish. But look at 0 there. Wow! If you've got a 0, it looks like you've got a massive old chance of not surviving. But that's actually an illusion of the data. What's 0? 0 is that I didn't know what your cabin number was. So I'm not really sure if we can be using that because it is a pure illusion. Chances are the reason that it's so overinflated is that, as I say, the passenger manifest was lost and they interviewed survivors in order to get this data, and consequently only those who survived tended to be alive in order to remember their cabin number. Those that did not survive are unlikely to be able to provide us with this data. This is my favorite type of chart. This is a heat map. So there is a process. It's very mathsy and complicated, and I'm not going to relay it now, but there is a process by which you can take one data column and another data column, crunch the numbers, and it will tell you how related are those two data columns. And it will give you this in a value between -1 and 1. -1 and 1 means they correlate perfectly. 1 means they correlate perfectly in proportion to each other. -1 means they are perfect in inverse proportion. As one doubles, the other halves, and so on. 0 means they have absolutely no connection and they are random to each other. Very few things are true zeros, but a lot of things come pretty close to it. Now, the data is basically duplicated on both sides of the graph here. The one stripe there is comparing each column to itself. It's an automated process. It just does that. So you can ignore those ones. They seem useful, but they're not. But what we're looking for is any other strong colors. Strong red indicates closer to 1. Strong blue indicates closer to -1. So the things with strong colors we want to look at. So what have we got? What have we got? We have got a very strong correlation between the number of siblings and the number of children. That's not terribly useful. What else have we got? We have a correlation between survived and the fare you paid. Yeah, I did say it's a thing. And sex. Sex is a huge one. 54% correlation. So this sort of suggests that that old rule of the sea, women and children first, was obeyed on Titanic and might be significant. So this is, let's just zoom in on just survived. First off, ignored the one that survived against survived. Yeah, they correlate. How about that? Totally useless, but interesting. So, what is correlating, though? Right, so as I say, sex, 54% correlation. Yes, that's meaningful. We have cabin letter with a 30% correlation. That's pretty good. That might be useful. 26% correlation with fare. Now, the rest are all fairly low-ish. I mean, there's maybe embarked, which is actually a -13% correlation. Maybe. But it's getting... And then the rest are below 0.0%, so not probably very useful to us. Now, passenger ID there is just actually literally an ID value. Totally useless, even if it correlated. Let's now talk about ML.NET. That's what I'm actually going to be implementing my real solution in now. That stuff in Jupyter Notebooks was just to get a little bit of a feel, shape of the data, what fields do I want to focus on, what's likely to be useful. Now we've done all of that groundwork, we can actually get on with developing something. Now, ML.NET is incredibly powerful and incredibly useful, but relatively less known, which surprised me, but it isn't, which is why I'm talking about it. But it is also a full-on .NET solution, so this is more something you might want to use in production rather than something you're going to use to analyze your data. It's a little bit too heavyweight in terms of the need for code compared to necessarily do your analysis work if that's what you're doing. It's got a few ways of developing an ML model. The quickest and the easiest, but not necessarily the best, is you've got literally a wizard-based thing. It's basically like database first EF or something like that. You just feed it the data and stuff comes out. And it's pretty incredible. And it gets reasonable results, stuff that's usable. So we've got data classification. So that is which pot does this data go into? Value prediction, that is, I've got a range of values this could be. Which one is it? Recommendation, that's for Amazon and things. Forecasting, we've got image classifications, text classifications for if you want to get the tone of a text or work something out about text. There's loads this can do, but I'm focusing for now on those first two, data classification and value prediction. So, loaded the data into the system. There it is, going into my my Visual Studio project. This is now switching to Visual Studio 2022. VS Code doesn't really support this. There's an add-on that you need to go and install from the Microsoft website to be able to do this. So it's not really a VS Code thing. When you do, it basically drops one of these things into your project. It says mbconfig, but what it does, rather like EF again, it creates a whole load of static classes and some objects that you can instantiate and stuff like that, which are now just part of your code base and namespaced into your whatever your namespace is, and can be used as if they were just an ordinary part of your C# project, which indeed it is. If you look under there, because I've expanded it, you can see it's literally created a whole load of C# files to use. So let's see if this... and how you do it is rather like this. You go and get yourself whatever it is you want to do to parse your CSV and take your CSV, turn it into an actual data thing. Go and create an instance of the of the data type that it's expecting, which is usually something like whatever the name of that file is, .model input, and that will have all of the fields that you expect to feed into this, and then you call a function called predict, which will make a prediction, and then you can take that prediction, and in my case what I did is I just literally looped through each and every one of the test data set, run it through predict, and got an answer back, and then popped that into my answer file, and then asked for a score from Kaggle, which is what you can do. If you make an output CSV with the correct 0 and 1 format for the answer, it'll give you a percentage to say whether you got it right or not and how right you got it. A score. Right, and I used some dictionaries and stuff just to make it easy to look up like where I got the right answer, because I sort of looked up what the actual answers were. It's not because I want to cheat, because where would be the fun in that? I know there are a load of people that do that, and I have no idea why. It was more that I just wanted to process lots of attempts in a short space of time, and I just wanted to not have to bother Kaggle every single time, because there's actually a lock on how many times within a certain minute or so that you're allowed to ask it. So I just thought if I code all this into a unit test and put the real answers, and I can work out my own percentages, and that'll do just fine. Which is indeed what I did. So, I have some advanced data options. So when part of the wizard, what you have to do is select your data set, and it loads all of the fields based on the headers in the CSV, and then it attempts to put purpose and type and categorical or not to each one. So, purpose. There are 3 valid answers: ignore, label, and feature. Ignore speaks for itself. Ignore. Don't care. Passenger ID is an ignore because it's irrelevant. Survived is the label. The label is the thing I'm actually trying to predict. And then the rest are features. A feature means this is actually part of the data that I want to be included in the process when we make our prediction. And then the data type. There's only a couple allowed. Single, Boolean, string, and date time, I think, are the only supported datas. So the only numeric type that's allowed is single. That is, I believe that's double, more conventionally in .NET. So that's it. That's all you're allowed. So just bear that up. There we go. String, float, bool, date time, and that's all you're allowed. So you may want to be aware of that if you're taking data out of this and actually rendering it anywhere, because that's what you're going to get. Categorical data. So that was the tick box there, categorical data. So categorical data means that this can only be one of a discrete number of possible values. Title, Mr., Mrs., there's a ton of others, but there is still a limited number of supported options. And so therefore, species, cat, dog, human. You can be a cat or a dog, not both. Human politician, you can be human or a politician, not both. Handedness, left, right, or ambidextrous. Yes, you can be both-handed. That is itself a discrete value. You can't be both ambidextrous and left-handed without necessarily also being right. You see what I mean. Color. Now, I'll get to that in a minute. Color, red, orange, blue. There are many, many, many colors. That's categorical. But color's an interesting one, because there's also continuous data. Okay, age is continuous. It is any value between 0 and theoretically about 120 is the theoretical upper limit of human life. The price of a sandwich. And color. Because color's both. Bear in mind that the model is not the thing. The model is a rendering of the thing. It's a rendering that is useful for some reason. If you want to make color categorical, that is to say red or yellow or whatever, then make it categorical if that's useful. Otherwise, if it is more useful for it to be continuous, then use things like RGB values. That's continuous. Which is more useful? It's up to you. Depends what you're trying to achieve. None of that's terribly useful for Titanic. I mean, it all depends on what model you are working to and what the data means to you. So, purposes. Talked about those. Feature, label, ignore. Okay. So I've tried to plug all of these in as best I can. Passenger ID, ignore. Survived is the label. I've said that passenger class is a categorical. I've ticked that. It's a single because it's numeric. It's a feature. Name is a string. It's not categorical because everyone's got a different name, or at least everyone that was on Titanic did. And you get the idea. And I've applied these principles to all the rest. The stages of the process are... Yes. And by the way, it actually comes up with this in a matter of seconds. In fact, you can tell it how many seconds you want it to run for. What actually happens is, if you give it more time, it just tries more ideas out. It doesn't keep super overtraining. If you give it 5 minutes, what it'll do is spend about 10 seconds or so at a time trying a different model, trying a different trainer, trying a different way of doing this, and then at the end of it, it comes back with the best option it found based on all the data, whatever it tried. So when you run something through ml.net using the wizard-based approach to just drop it into your project automatically, you're basically getting its attempt at the very best possible solution. If you know your data better, then you can hand code it, and I'll get into that. But this is a really simple, quick, couple of minutes job to drop into your project. So the stages: data refinement, fill in missing data, train, and then predict. Okay. So there's our data, and let's have a look. Right, what extra data can we get out of this first? Because it's worth bearing in mind that just the straight-up data isn't necessarily the no, that's not rendering very well. Oh well, done now. The best way to do it. We've got these. These titles are useful. Titles are useful. Now, they're part of the name, but the title tells us something about age. So a lot of ages are missing, so we can actually extract the title to have an indication, potentially, of how old someone is. So that's useful. There's a whole load of random sort of titles too, but these are all uncommon. I mean, who comes up with these names? Lady Duff Gordon. If I were making up a posh lady to be on my Titanic in my film, I wouldn't call her Lady Duff Gordon because that's just too obvious. But nevertheless, the Reverend Charles Leonard Kirkland. Wow. I bet he did it in Cluedo. I bet he's the one that did the murder. Right. Okay. How do we do these sorts of things? Well, this is the sort of transformation we can do in the .NET world. Just literally get ourselves a title. And I've simplified. I've either taken the title and then simplified it. If it's for example, if it's Miss or MLLE, which is short for Mademoiselle or Ms, then I can simplify those because they roughly mean the same thing. I mean, yes, they're not the same thing, but for our purposes, when all I want to do is ascertain their rough age, they're good enough. So trying to simplify your data down into a meaningful form is worth doing, and this is an example of how it get done. And then for the rest, I just simplified them down to rare because it probably doesn't matter. There's only a handful of them anyway. Cabin number, can we get anything extra from this? Well, this is pretty useful. This is cabin numbers. The first letter is actually telling us which deck they were on, which is significant. Unfortunately, most of the cabin numbers are missing. So, and a lot of them look like stuff like this. I don't really know what this means. I mean, did these people buy 3 cabins? I suppose they did, but the data's a little inconsistent this way. But there's so much missing data that it's questionable as to how useful this really is. But you can do something like this to generate your cabin number. Just literally take the first or default. And doing that, I got a 77.75% accuracy. That's actually pretty good. I mean, that was done with a couple of button clicks and a few lines of code. That's hardly anything. 77.751%. I'm okay with that, nearly. But let's see how much better I can make this, because that's just an auto model. So the auto model's pretty good. Let's see how hand cranking our own solution, whether we can do better. So I have mentioned the missing data. We've got to make an effort to fill this in. So let's have a look at how we'll do this. Age needs to be filled in. Cabin, 687 missing values out of 800 missing values. Basically, we really only have the details of the cabin number of a handful, so I'm not sure that's useful, but we can fill that in. So let's put a pin in the idea of the calculate age. I'll show that in a minute. Embarked, to be honest, there's so few missing embarked values. If we look back a moment, 2. I'm not really going to lose any sleep over those, so what I'm going to do is replace them with the mode being the most common one, because it's probably right, and it's probably not significant enough to affect the model, except maybe those 2 scores. Okay, so value prediction. Let's have a look at this. This is the same thing. So you take your data and select the data items you think are useful, whether it's categorical, which type it is, and so on. And then I gave it about 60 seconds to generate a value prediction. Now, the difference between a value prediction and a categorical prediction is the value is a range of values. When it's categorical prediction, then that is like determining which category it belongs to. It's just going to be this or that. Whereas this is going to be anywhere between 0 and 120. And it's continuous. It can be anywhere between those values. And what it came up with after 5 models it tried, and then the best model it found was fast forest regression, and that's the one that the auto model decided to use. This is what it looked like using that prediction model. So it predicted 28.9, actual 28. Yeah, it's about right. Charles Eugene Williams there predicted 32, he's actually 23. Well, it's still in the order of magnitude. He's a relatively young man. It's not totally wrong. It's at least, it's more useful than the values missing. That's more useful. There are some, though, occasionally that are wildly wrong, but broadly speaking, you can see that the prediction is roughly mapping to kind of the category of person to which it belongs, and that's useful. So our refined process now. So now it's a 2-step. I've got 2 ML.NET entities dropped into Visual Studio, one for predicting age and one for predicting the survived or didn't. So the process now is load the data, refine the data, that is get our virtual fields sorted out, cabin number, title, stuff like that. Train the age predictor. So now I've got an age predictor, use the age predictor to fill in the missing ages, which means I've now got a refined, filled in set of training data, and then train the survival predictor based on this modified training data set, and then use that model to predict survival. So, how much better do we think this was? Do we thinking a little bit better, a lot a bit better? What's everyone thinking? No. Well, it's not 77.751% anymore. It is 77.99. How much better is that? Like, you know, a little bit. It's, yeah, fine. But the thing with this challenge is that, honestly, it takes a huge amount of work to get yourself an extra percentage point of accuracy. And you probably need to use some really hardcore mathematical processes in order to really get high results, and those aren't really available in .NET at the moment. So what else can we do? Let's have a look. This is how I store my data classes. So I've made my own models to represent the CSV that goes in and the one that goes out, and I've got column names and low columns because that's the way that the CSV parser I used works. You use attributes to mark the classes properties to let it know what it is that where it is inside the CSV, and then called this is what the training model system looks like. I'm basically converting the model that represents the CSV into the model which will be understood by the, well, this is actually just parsing the CSV, but then I'm processing this, passing in custom mappings. Now, custom mappings this is how we add in our virtual fields. What you do is you create a new custom mapping type. Now, there's actually an internal data structure inside ML, which I don't know how it works entirely, but we interact with it using reflection, I believe. Because you basically create classes which have the same property names, and then it reflects the value into that class when it's called. So for the custom mapping, what I do is create a transformation input and a transformation output, and the input has got properties which match by name those inside the model, and then the output is the things I'm creating, and then you pass it each of these, and then use a lambda to take in whatever from the input, that's whatever was relevant to you from the source data, to create this new data and then pass that out. So you just pass it, basically. When you're making what's called a pipeline, that is a series of transformations, the custom mapping transformation is just like this. The data you needed in, the data you created based on it. I also created one called family, which is a sum of the number of siblings and spouses and the number of parents and children, add them together. I made a Boolean field because I was experimenting at this point with this idea, and that's whether you traveled alone or not, because that might be relevant. I tried a lot of ideas out to try and get more. This is what our custom transformations look like. As I say, no real mystery behind what these are, no custom attributes. I think under the surface reflection's what's used, but I don't actually know. and then just append it. Now, I've also got some built-in transformations appended in my custom pipeline I'm making. One hot encoding is an out-of-the-box way of saying that this is categorical data and it has to be made numeric. That's what it is. It's basically under the surface doing the exact same thing I did in Python, take something like embarked and then replace each of the categorical values with numeric values, which are somewhat arbitrary. They're probably doing it better than I did in Python with something a little bit more reasonable. And a normalize is exactly what it sounds like. It's a normalize transformation. It's just normalizing fair and age to try and make them a little bit statistically easier to pull apart. Okay. And then, to actually use it, I create an ML context, which I keep comparing it to entity framework. That's basically the same idea. It's a context. Create a new ML context. You've got a transformer, which is something that does the transformations. Append to this transformer each of your transformations, and then do a fit. You give it the training data, and it fits. It makes a model, and you can then store that model. That, in fact, you can either store it by storing data out of it. You can have it dropped into a file that you can then store on the file system, or just create it each time you call up the model. However you want to do it. Depends. It depends how expensive, difficult, and time-consuming the transformation process is. So then, having done all of that, having made my custom pipeline with each of the transformations appended to it, selecting the data to the correct ML input model, load from the data in, it's load from enumerable there, transform it, and then preview there I've put in as a something that just, preview is something that I find useful for debugging purposes. Preview contains both the prediction and loads of metadata about it, so you can have a look and try and reverse engineer what's going on if it's not as good maybe as you wanted, and then create an output which is just basically append it all into a new class with an extra survived predicted label there. You can get things like how certain it was if you want and stuff like that. There's loads of metadata available for the prediction. And it's no longer 77.99%. That was all custom transformations. So what are we looking like now? 78.947%. Okay, it's still not, I mean, I would have loved to have gotten this above 80%, but I mean, it's not going to happen without doing some really serious additional work that I haven't the time for. But that's still pretty good. I mean, 78, nearly 79%. That's gone from being like a beginner's attempt at this into we've got something that's kind of fairly serious and useful. It's still right most of the time. There's only about 20% of the passengers it gets wrong. And you can probably still continue. You're never going to get all the way up to 100%. Let me say it this way. That's not going to happen, not in the real world. Because if someone was the richest person on board Titanic and had a cabin right up the top, but it just so happened that on the way to the lifeboat they tripped on the stairs and fell over and missed the boat, machine learning can't predict that stuff. What if there was a stowaway who by right shouldn't have survived but was sitting in the boat and snuck in? Machine learning can't predict that stuff. Machine learning cannot predict the fate of individuals, as Isaac Asimov put it once. All it can do is predict populations. As a whole, as a population, as a proportion of a population. Those are the sorts of predictions we can make. So you can never get to 100%. Not really. So, who wants a go? This is a website that I've put together. This is the actual code, and this is a web app which you can all have a go at, and you can put your own particulars in and find out whether you yourself survived your trip on RMS Titanic or not. By the way, no data is recorded whatsoever by this. All of your data is safe. Nothing's recorded. It basically spins up a new instance, and everything is held in memory. And when the instance finally closes itself down when no one uses it, all that data is wiped. Not that I store it anyway, because why would I? If anybody doesn't even want to put in their real details, don't. I don't mind. If you feel for various reasons, bringing up the gender thing again, if you feel you don't fit into one of those, that's perfectly valid. Just make up a character, and then let's find out about your character, is my suggestion. So have a quick go. It's not the best web API I've ever made, nor the best interface I've ever made, but it's good enough to have a little bit of a go. So I'll just give you all a minute or two to have a go. Incidentally, there is another ML.NET talk happening today, I think later today. Peter Nace, is he here? He's over there. Tomorrow, my mistake. He's right there. So if you want more ML.NET goodness, there is literally a person over here who can answer all your questions while I run away and pretend to be somewhere else. Has everyone managed to have a go who wants to? Is there anyone still typing? Okay. Has everyone got a prediction? Ooh, okay, this is going to be interesting. So what I would suggest is, if you survived, pop your hand in the air now. Not very many of you. No, 1, 2, 3, yeah, about a dozen. Thank you. So you get the idea. Now, feel free to have a little play around with the values, but what I suspect you will find is, if you say that you are female and wealthy, you'll probably have a fairly strong chance of survival. If you say that you are male and not terribly flush, you're probably going to get rather a low chance of survival. Those are the two biggest factors in determining survival or not in this particular instance. Incidentally, there is if anyone wants to have a go at this but don't like the idea of using actual real-life data from a real tragedy, which is reasonable, there is also a version where they just literally made it up and it's all on board a spaceship or something. So you can have a look for that if you want as well. But this just, I don't know, there is just something nice about the idea of using real data with real data problems that I found very, very engaging. What else can we do? Ensemble learning. Now, this is something I sort of thought about and never actually implemented, but ensemble learning is the idea that you have actually got a whole load of different models and a whole load of predictions, and what you do is sort of read the room. You read what is the consensus of expert opinion, because different models produce different results, only slightly, but it might be enough to get a bit of a feel that, to remove some of the outlying false positives or false negatives from one model by reading the room of all the models. So that's an option. Clustering ages into groups, making them categorical. I've heard some people have had good results with that. Clustering ages and sexes into group. There is the gender surname model, which is making clusters based on your gender and your surname. It's sort of to put families together, basically. Families who aren't necessarily in the same cabin. It gives you an extra level of data. The woman-child group model, once again, same sort of idea, but takes it further. Includes things like nannies and the like. So you get a little extra. Because what tended to happen is, as families survived as a whole or didn't, if they had young children. So that sort of thing. As gradient boosting. Now, gradient boosting is not currently, to my knowledge, supported by C#. Gradient boosted is heavy mathematics to take each of those fields and render them into a form which is much better for making these separations between the categories. But again, to my knowledge, not currently supported, so you'd have to implement it yourself, if that's what you like. This is a copy of the code, if anyone would like it. It's all the code I wrote. Feel free, grab it, have a go. I don't mind. It's all on my GitHub account anyway, so even if you don't scan this now, look me up on GitHub. You'll find my code. It's all there. Feel free. If you manage to make any improvements, let me know. I would be delighted if someone found a slightly better way than I did and got a better score with ML.NET. Most of the really high-scoring stuff is, of course, all Python, because Python. I mean, I like Python, and it's named after Monty Python, so I like it doubly for that. But, yeah. If anyone is interested in reading further on C#, I wrote this book, Functional Programming with C#. Functional programming is kind of my thing. I do like it. In case anyone is interested, I did not get to choose the animal. We just get them assigned to us. And the book took 2 years, and it is very silly, because I wrote it, and that's the way I write. I kept putting jokes in, and Riley didn't take them out, so I put more in. And that's how it ran for 2 years. It's very silly indeed. It is the only programming book in the world I'm aware of with a post-credit sequence. Yeah. If you want to read more about machine learning, both of these books are excellent. Statistics by Witte and Witt, I'm not totally certain, published by Wiley. That is basically a book on statistics, because if you really want to get into machine learning, honestly, learn about statistics. That's what it's all about. The 100-page machine learning book is also really good. It's a very high-level sort of whistle-stop tour through the whole world of machine learning. It's excellent. It is also available as a website for free, which is my favorite price, but I am the sort of nerd that takes these sorts of books to bed to read in bed, so I own a hardback copy of this book, and it is most excellent. And this brings me to the end of the talk, and this is and the Titanic. This is the last known photo taken of Titanic as it disappeared off into the Atlantic on its final voyage. So, with that, I'd just like to say thank you. Oh, don't think that's don't click that link. Sorry, but I'd just like to say thank you very much indeed. And if you have any questions, I will be here. Thank you. there any questions quickly, by the way? We have a minute, but feel free to disappear if you've got places to be. I don't know what the time is. You maybe have places to be. But I'm here if you want to ask me anything. Or Peter's over there. Ask him. He's much cleverer than I am. Honest. Thank you. It's the green one. The green one. Thank you.